Yeah. Hi guys. Good evening everyone, and thanks for joining the session. Today we are going to learn one of the important topics in the security, which is an IPsec. I think most of you learn IPsec in the CCNA, right? So we'll learn once again here in the Palo Alto firewall. So mostly IPsec will work on the layer 3. Okay, so in the name itself we will be having an IPsec. Okay, so IPsec means Internet Protocol Security, which works on layer 3. As of now, before IPsec, there was no security on our L3 traffic. So in order to provide security on L3 traffic, so they have introduced an IPsec. So most probably, so this IPsec will work between the sites. Okay, we can also call IPsec as an site to site VPN. Okay, so site to site VPN means whenever you want to transfer any information, or whenever you want to forward some confidential data from your branch offices. Okay, let's assume you have an company where you have multiple branch offices. One branch office is in Hyderabad and one other in Kurnool, or one more branch office in Bangalore. Okay, likewise you will be having multiple branch offices. Whenever you want to share some information which is confidential to your company, or which is which you don't want to expose in the internet, so there this IPsec will be very much useful to transfer your data in a secure manner. Okay, so how this IPsec is going to secure data, and how the information will be kept confidential, and how the data will be exchanged between your branch offices securely, we can going to learn. Okay, before going to that, IPsec is an security protocol which works on layer 3, and it is going to use an UDP protocol, okay, with port number 500. Whenever you capture a packets, so you can see an UDP protocol. Under the UDP protocol you can see the IPsec payload. So the L4 packet, okay, whenever you capture the packet captures, you will be having TCP, okay, UDP header. Under that UDP header you can see source port 500 and destination is also 500. Okay, so source port 500 and destination is also 500. Okay, so this is some general information you want to know. Now how the IPsec is going to provide security to your data means there are four essential features. Okay, four features that are four features are used by IPsec to protect your data. Okay, to protect the data or packets, or we can call as an traffic. Okay, so what are those four features means? The first feature will be, okay, will considered as first one is an confidentiality. So what is confidentiality? Okay, what is confidentiality means whenever you are sending a data, okay, whenever you are sending a data from your Hyderabad branch office to Kurnool branch office, so these data no one has to be see that data. Okay, no one has to be see that data. So that's where the confidentiality will work. So this confidentiality will be, okay, using encryption algorithm. So it is going to encrypt the data. So and once it is leaving from, okay, once it is leaving from the firewall, it is going to encrypt the data, and once it is encrypted, so no one no one in the internet will be able to see the message or see the data. Okay, no one will be no one in the internet will be able to see or read the message or read the data. Okay, so this confidentiality will work by encrypting the data. So we are already discussed about what is encryption, what is decryption. and how the encryption will do, how okay decryption will do, right? So encryption in sense we are converting our plain text into some cryptographic text that will be taken care by encryption algorithms. Okay, so whenever you are sending the data, okay, the before the data leaves the firewall, it is going to encrypt and it sends the data over the internet. Okay, so we will be building a tunnel, right? So obviously it will reach the firewall too. Once the firewall 2 receives the data, it is going to decrypt. Okay, it will decrypt and it will be forwarding the data towards the destinations. Okay, so this is how the confidentiality will work. And second one is an integrity. So this integrity, how this integrity will work means whenever we are sending the data, no one has to be modified. Okay, confidentiality, we okay our data no one has to be read what exactly contains in the data, no one has to be read. But whenever you are sending the data, so there may be a chance of modifying your information, right? So to avoid that, we are using an okay IPsec is using an integrity. So whenever we are okay whenever the IPsec uses integrity, so no one in the internet will be able to modify the data. Okay, so for integrity the IPsec is going to using an hashing algorithms. So it is going to do okay hashing. Okay, uh, to the data, it will do a hashing to the data so that no one in the internet, no one in internet will be modify the data. Okay, so let's suppose you are sending some information, if they are accessing and they are trying to put their own information, right? So that information whenever you receive on the firewall too, there may be an there may be an unwanted links, or there may be sharing some they may be sharing some unwanted data to your other branch office to get information from them. So to avoid that, we are going to hashing the data so that no one in the internet will be able to modify except the sender and the receiver. Okay, sender means whoever sending the data, receiver means whoever receiving the data or information. Okay, this is the integrity that it is going to work. So next one is an authentication. So authentication will work. Okay, so why we are using authentication means whenever you are sending an information or whenever you are receiving the information, so we have to know whether we are sending or we are receiving the data from correct. Okay, correct sender and the receiver. So whenever you are sending the data from here, okay, whenever you are sending the data from Hyderabad firewall, let's assume there are multiple users in the internet, right? So maybe they will take the data, maybe they will hide okay whatever the information that you are sending from Hyderabad firewall, and they are trying to send their own data. Okay, they are sending their own data. Whatever we are sending from Hyderabad, they will be getting hide that data, and they are trying to send their own data. Okay, at that time, if the firewall has not authenticated with firewall 1, or otherwise if your kernel branch office firewall is not authenticated with Hyderabad branch office firewall, maybe they may chance of accepting the information, and they may be introducing some unwanted or suspicious information in your branch offices. Okay, so that may leads to that may leads to entering they are entering into your network, or that may leads to uh, s- okay they will be capturing your data. Okay, so to avoid that, we need to do an authentication. Okay, so if you are getting an information from right right device, or okay right sender, or if you are receiving if you are receiving the data from correct receiver or not, we need to do an authentication. Okay, so in this authentication, so we have multiple types of authentication. Multiple instance, we have two types. One is an you can use pre-shared key or the certificates. Okay, so we can use an certificates or pre-shared key here to authenticate with the devices between your branch offices. And next, the fourth one is an anti-replay. The fourth thing is an anti-replay, where it is going to work as, okay, it is going to work with the sequence numbers. So why the sequence numbers means, so whenever you are sending the information, even though you have encrypted and even though you have authenticated with your branch office firewalls, there may be some attackers or there may be some hackers who are using some advanced tools to crack your data or to get, okay, what exactly contents in your okay, what exactly contents in your message. So they are trying to crack your data, okay. So in order to avoid that, or in order to know whether the data has modified or not, we are using a sequence numbers, okay. So whenever we are sending a sequence number, okay, whenever we are sending an information from here, this firewall will attach one sequence number with that. And also both firewall and firewall 2 will negotiate with the same sequence number, okay. Let's assume we'll be having an 123 as a sequence number. So they are going to negotiate with this firewall 1 and firewall 2, it is also containing the same sequence number. Let's assume you are sending an information from firewall 1, okay. So you are sending the information from firewall 1. This, okay, hacker has uh, captured your data and he has modified with its own data, okay. He has included some unsuspicious, okay, some suspicious links, and or he may, okay, he may add his own information there, and it is going to send to the your firewall to, whenever he has modified the data, this sequence number will get changed, okay. So here, whenever the user or whenever the attacker modified the data, let's suppose it has modified to 456, the sequence number will get to change to 455 456, okay. So now the packet or the data comes with this sequence number, okay. Once the receiver or the firewall to receives the packet with sequence number, with this sequence number, it is going to try to match this sequence number with its sequence number it has. So it is not matching, right? So it will think that there is something has changed in between, or there is something, the message has modified in between, and this firewall will not accept this, and this packet will be considered as duplicate, and this packet will be dropped here, and the firewall 2 will not accept, okay. So this is how the anti replay will work. And these are the four essential features that IPsec is going to use to protect the data, okay, and to forward the information between your sites in a secure manner, okay. So any questions here?
Bro, UDP is a unreliable protocol, right? But here we are
Yes.
using that one only in the secured
Yeah,
tunnel.
this IPsec will not, okay, will not need any reliable transfer, or this IPsec don't need any acknowledgement for whatever the data we have received. So that is the reason it is going to use UDP. However, we are having an IPsec tunnels, right? That is, reliability is not needed in this. We need only the data has to be sent securely towards the destination. That's it. That is the reason the IPsec is going to use UDP protocol.
I mean, there is no guarantee to the data which has to be delivered, right? That's why.
Yeah, there will be a no guarantee, but obviously it is going through the tunnel only. We are building up a different tunnel, okay. We are building up a tunnel between your both firewalls. Obviously, once the traffic enters the firewall, obviously it will reaches the other side of the firewall.
Okay, bro.
Yeah. So here, after this features, okay, so we'll discuss these features in phase 1 and phase 2 as well. So here in IPsec we will be having, okay, two phases, okay. This IPsec is going to build between your firewalls in two phases. First, okay, phase 1, which it will be using to build, okay, phase 1 tunnel, okay. We can call it as an IKE phase 1, which is an so IKE means internet key exchange, which is also a protocol that is using by IPsec. So in this IKE, we will be having two phases, the phase 1 and phase 2. So mostly phase 1 is used, okay, in IPsec, the phase 1 is used to send an management traffic, okay, and as well as phase 2 information, okay, whatever the information that is required to build a phase 2 tunnel. So the phase 1 will be, okay, once the phase 1 builds between your branch offices, it is going to use to, okay, to share an phase 2 information inside the phase 1 tunnel, whatever the information that is required to build an phase 2 tunnel. So it will be sharing, or it will be forwarding, or it will be negotiating inside the phase 1 tunnel, okay, as well as this phase 1 will mostly use to, okay, send management traffic between the your branch office firewalls. So what exactly contains in phase 1 and what exactly contains in phase 2 means, in phase 1 we will be having a two modes here. So the first one is an main mode, okay, and second one is an aggressive mode, okay. So what exactly the main mode is, and how we are going to utilize this main mode in phase 1, and what exactly the aggressive mode and how we can utilize this aggressive mode in the phase 1, we can discuss. So and also at end of this phase 1, so we are going to learn which mode is more suitable in the phase 1 to form an phase 1 tunnel between the branch office firewalls, okay. So let's go with main mode first. So in the main mode we will be having six messages, okay. We will be having six messages, okay. The first message will always from the sender, okay. So if the Hyderabad firewall is initiating the traffic, it will be calling as a sender. So the first message it will be generating, and it is going to send to the kernel firewall, which will be called as a receiver. So if the kernel firewall is initiating the traffic first, it will become a sender and this become a receiver. So let's assume we have an Hyderabad firewall, and let's assume this Hyderabad firewall is initiating the traffic, no. So the first message is from the Hyderabad firewall. So what exactly content in the first message means, this first message will include security association parameters, okay. We'll call these parameters as an security association parameters, or we can also call SA parameters. What exactly these security association parameters contain means, so we have discussed about here hashing, right? So that hashing algorithm will be going to use here. So in the SA parameter we'll be using as, okay, the hashing algorithm will be using as SA parameters. In this hashing algorithm, we will be having two types of hashing algorithms, SHA and MD5. Okay, these are the two hashing algorithms that we have in that the IPsec is going to use. And after that hashing algorithm will be, sorry, authentication. After the hashing algorithm, we will be having an authentication algorithm. As we have discussed, it will be having pre-shared key or certificate. Okay, and after authentication, so it will be having an group. So here in this group we will be calling as an DH group. So in this DH group we will be having multiple group numbers, okay, like group 1 or group 2 or group 4, group 5, group 14 or group 19 and group 20. Like this we'll be having multiple groups. So why we'll be having these many numbers means, they have, whenever they have introduced an DH group, they have, okay, they have gone with the first group 1. Why they are using the group 1 means, so we'll be already having an hashing algorithm there, so which is going to, okay, hashing your data. So whenever we are hashing the data, no one in the internet, they are modifying your, okay, they are going to modify, they are unable to modify your information. But okay, as technology evolves, there are multiple tools or introduced, and the hackers are going to use some advanced, okay, tools to crack your or to capture your data and see what exactly lies in that, and they're trying to modify the data. So to okay to in addition to the hashing, so they have introduced a group with DH group. DH means Diffie-Hellman group, which will be also going to support the hashing by generating an key here. Okay, so along with hashing, the DH group will be going to generate a key, so that this group these groups will be helpful to create a key. So whenever there is a group number, so the if the group number is higher, the key value, the key length will be very long, so that the hackers or for the hackers that will be difficult to to crack that key. And they, if they want to try to modify the data, they first they have to crack this key. Okay, so if you are using group one, there will be an the key will be very very small length, and maybe they are trying to uh, crack that key. But whenever you are using the group 19 or group 20, the key length, the key value length will be very big. That will be difficult for them to crack the your information. Okay, so this Diffie-Hellman group will be used in such a way that it is supporting the hashing. It is using along with the hashing, so to calculate the higher key value, and that will be difficult for the hackers to crack your information. And after the group, we will be having a lifetime. So this is mainly for the tunnel lifetime. Okay, so like how you have DSCP lease time, so here also each phase 1 tunnel and phase 2 tunnel will be having a lifetime. So the lifetime will be like, by default we can see 8 hours as an the phase 1 tunnel lifetime. So if that okay we mention 8 hours, right? Whenever there is 90% of lifetime completes, 90% of lifetime completes. Okay, so what firewalls will do means, firewall will be going to negotiate these SA parameters. Okay, so these SA parameters are going to negotiate once again, and to make all the parameters has not changed. Okay, so let's discuss this lifetime later. So after the once it completes all the messages in the main mode, I will discuss this lifetime, because if I tell you right now, you will make it confused. So why we are using the lifetime means, I will tell you once six messages are completed. Okay, so just remember that once the 90% of lifetime completes, the both the firewalls on both sides will again renegotiate the parameters. Okay, so that we just remember that thing, we'll discuss that once or six measures are complete in the main mode. After the lifetime, we'll be having an encryption. Okay, so it is going to use encryption algorithm. We will be having AES, 3DES and DES are the encryption algorithms. Okay, these are the parameters that okay uh, firewall one, which is our Hyderabad firewall, is going to include. And in the same way, once this once the first message received on the firewall 2, the firewall 2 will also generate an message which will be calling as a second message in the main mode. It is from the firewall 2, which is the kernel branch of his firewall. It is also contain the same parameters. Okay, why we are why we are using these means, so in order to form an phase 1 tunnel, so all these parameters should match. Okay, so to form an phase 1 tunnel, all the parameters should match. If any parameter is not matching, if any parameters configured wrongly, so the phase 1 tunnel will not form. Okay, if you are using sha on firewall 1, you have to use same hashing algorithm sha on other firewall. If you are using MD5, you have to use MD5. Okay, and if you are using the pre-shared key on one side, you have to use same pre-shared key on both sides. So if any of the pre-shared key, if you are using pre-shared key but The pre-shared key is also like something like an password. Okay, let's take I configured pre-shared key as tbn at the rate 12345. So this is a pre-shared key that I configured on one side. So on the other side, if you configured tbn at the rate 1234, so it is not matching, right? So if you are using pre-shared key, the pre-shared key also should match, then only the tunnels are going to form, otherwise the tunnels will not form. Okay, tunnels in sense phase 1 tunnel will not form. And here, after the authentication, you will be having group, right? Group number also should match, whatever the group number we are using here, the group number should also match, the lifetime also match. If you are using 8 hours, you should use 8 hours. And the encryption also should match. If you are using AES, you have to use AES. If you are using 3DS, you have to use 3DS as well. Okay, so likewise, so whatever the parameter that you are using on one firewall, you have to use the same parameters on other firewall. This is in our hands, we need to configure these things. Okay, if you configured everything right, okay, if you are configuring everything and still if you are, okay, phase 1 tunnel is not coming up, you have to verify the configuration once again, whether any of the parameters are configured wrongly or any of the parameters mismatching, that may be causing the phase 1 tunnel will not come up. Okay, so these are the two messages which are very important in the main mode. So where they are negotiating the parameters. So once the two, okay, two messages completes, there will be a third message from the sender. So in the third message, the key exchange will happen. Okay, so here it is going to here it is going to use dh group with group number, right? This group number will be used to create a key, and it is going to exchange in third and fourth message. Okay, the key that is generated on the firewall 1, which is in Hyderabad, okay, it is going to exchange in third message. And in the fourth message, so whatever the key exchange that it is generated by the firewall 2, it is going to exchange. Okay, and next we'll be having an fifth and sixth message. So in the fifth and sixth message, mostly the identification information will be shared. Okay, so what are those identification information means? Whenever you are sending an fifth message, this identification information will contains your, okay, your local network information. Okay, so this local network information in sense, it will contains, okay, private IPs, or it will contains any of the usernames, or it will contains private network, private subnets. Okay, it will contain, because it has to be, the other firewall has to be identify what exact your okay, your local subnet, okay, your local users, to in order to identify the other firewalls, we are including this in the fifth and sixth message. Okay, so this fifth and sixth message contains, okay, private IP information. And also maybe you can use a user, okay, user information as well. Okay, maybe you can use any user names, or you can use any user credentials there. Okay, so there may be an private IP or user information. Okay, and we are sending then private IP and user information, right? So whenever you are sending a private IP and information over the internet, we are mostly concerned about our private networks only. So in the main mode, the fifth and sixth messages are encrypted. Okay, why? Because we are sending, or we are sharing our private information, or we are sending the, okay, confidential information. That is the reason in the main mode, the fifth and sixth messages are encrypted. Okay, so here also it is going to send an identification information. So this sixth message is from firewall 2. So firewall 2, whatever the local subnets are available, okay, in the under the firewall 2, it is going to share, or it is going to attach in the identification information of six message, and it is sending to the Hyderabad firewall. This Hyderabad firewall want to know, right, what exactly the local subnets of firewall 2. So that's the reason we are sharing. So whenever we are sharing, so this information will be in encrypted format. Okay, so here the fifth and sixth messages are in the form of encryption. Okay, encrypted. So these are the six messages that we are going to exchange in the main mode. So tomorrow when we do the lab, okay, I will take the packet capture and I will show you the six messages, these six messages, and what exactly content in each message I will show you. Okay. So I told you to discuss about the lifetime, right? So why we are using lifetime means, so once these six messages are completed, okay, these six messages are negotiated, we are going to form an, okay, let's, I will draw, okay, take one more diagram here. Okay, once six messages are completed, so we are going to build an phase one tunnel. Okay, so we six messages are successfully negotiated between firewall and firewall 2, and we have formed an IPsec phase 1 tunnel. So this IPsec phase 1 tunnel will be having a lifetime of whatever the lifetime that we have configured. So once this lifetime completes, so it has to be renegotiate the parameters once again. Okay, let's suppose, okay, you have a lifetime of 8 hours. Within the 8 hours, maybe you have changed some configuration, IPsec configuration here. Okay, and the same okay, here in the firewall too you have same configuration, but on the firewall you have changed some configuration. If this life, okay, if this whenever this 90% of lifetime completes, it is going to negotiate the parameters once again from firewall 1 to firewall 2 and firewall 2 to firewall 1. So whenever there is some changes in your network, okay, configuration, if any if any parameters are mismatching, so what firewall will do means, firewall will be going to break your the phase one tunnel. Okay, or you, it is going to, okay, break your IPsec tunnel. Whenever there is changes in the configuration, it is going to break your okay, IPsec tunnel, right? So if IPsec tunnels break, so our information will not be shared between the branch offices. Okay, we are unable to share, or we cannot reach the other side of the branch office. Okay, so that is the reason we will be having a lifetime. So if you have a less lifetime, that will be a more secure. Okay, more secure in sense, so if you have 8 hours, okay, every 8 hours the firewall will be renegotiate the parameters, or we can call it as a rekeying. Okay, rekey, which are going to negotiate the parameters. Okay, so how often it is going to negotiate means 8 hours. Okay, within the 8 hours, if 90% of lifetime completes means, maybe 90% instance, maybe 7 hours or 7.5 hours. Once the 7.5 hours completes, it is going to renegotiate. It is just same like your DSCP lease time. So in the DSCP you will be having a lease time, right? So if lease time completes, okay, if you are having a lease time of 8 days, so 50% of lease time completes, so the client will send an okay, IP renewal for your, okay, IP renewal to your DSCP server, right? So in the same way, it is also going to once 90% of lifetime completes, it is going to renegotiate again to have all your configuration intact. Okay, all your configuration matching with other firewalls or not. Okay, now we have completed our phase one. Okay, this is a main mode. If you are using a main mode, this completes your phase one. Okay, let's discuss about the aggressive mode now. So in the aggressive mode, we will be having only three messages. Okay, we'll be having only three messages. So in the first message itself, it is going to share all the information that we have discussed here. Okay, so whatever the, okay, let's suppose we'll be having a firewall one. So from the firewall one, it includes in the first message, what includes means, in the first message it includes SA parameters, whatever we have discussed here. Okay, all the parameters, hashing, authentication, group, lifetime encryption. It is also include key exchange. Okay, and after the key exchange, it is going to include identification information. Okay, and this is from firewall 1. Okay, once this first message receives on the firewall 2, the firewall 2 will respond with okay, second message. In the second message also, it is also contain SA parameters from firewall 2 and firewall 2 key. Okay, that is going to exchange here, and also whatever the private subnets that are available under the firewall 2, it is going to exchange in the identification information. Once these two messages received, they are going to, okay, negotiate, they are going to verify the SA parameters first, and if any of the parameters are not matching, so it will not form an phase 1 tunnel, and if all the parameters are matching, the phase 1 tunnel will be built, and will be having, okay, the third message isn't some dummy message, okay, it will having some, okay, acknowledgement from the firewall one, and it is a dummy message, it doesn't contains any information, all the information will be shared in first two messages itself, okay. But which mode is going to use, okay, can anyone mention, or can anyone tell which mode we are, if you want to build a phase 1 tunnel, which mode we are going to use, or which mode is more secure between your branch offices to form an phase 1 tunnel? Anyone?
Main mode.
Main mode, okay. Any other answers, others? Yes, guys, I got one answer, main mode.
Actu- Bro, actually, in two phases, the information is sharing is that. I mean, whatever the information which is shared
Uh-huh.
is same, right? So
Yeah,
why there are
same,
two modes?
same only. So here whatever the information that we are sharing here, that is also going to share here in the aggressive mode, but we want to use only one mode at a
Even
time. So what is, which mode we can use, okay, so that our our data will be more secure.
it is main mode only, but
Main mode,
I mean, like,
okay.
yeah.
Any other
Sir,
answers?
Kartik sir.
Yes.
Sir, ఆ టూ నోట్స్ ఇంపార్టెంట్ అయినా సార్ కంపల్సరీగా?
Yeah, two modes important, but we have to use only one mode at a time. But I'm asking which mode is more secure and why.
మెయిన్ మోడ్ సార్.
Okay, I heard most answers main mode. Yeah, okay. Okay, main mode is correct. But why we are using main mode?
మెయిన్ మోడ్ ఓన్లీ 6 మెసేజెస్ ఓన్లీ విల్ బి యూజ్ సార్.
Aggressive
6
mode లో ఓన్లీ
మెసేజ్.
3నే ఉన్నాయి కదా. Aggressive mode యూస్ చేయొచ్చు కదా మెయిన్ మోడ్ కంటే. Why we are going with main mode? And why we considered main mode is more secure than aggressive mode?
8 అవర్స్ 90
Sorry?
8 అవర్స్ వర్క్ చేస్తుంది కదా సార్ లైఫ్ టైంలో అందుకని.
ఇక్కడ కూడా 8 అవర్స్ ఉంటుంది. లైఫ్ టైం 8 అవర్స్ ఇక్కడ కూడా ఉంటుంది.
Because of hashing algorithms,
హ్యాషింగ్ అల్గారిథం ఇక్కడ కూడా మనకి హ్యాషింగ్ అల్గారిథం ఉంటుంది.
encrypt.
ఐ టోల్డ్ ద సేమ్ ఎస్ఏ పారామీటర్స్, ఇక్కడ కూడా హ్యాషింగ్ అల్గారిథం ఉంటుంది.
మరి అది పార్సల్ పెట్టచ్చు.
I think we have discussed this in CCNA IPsec as well. So we are going with main mode because the fifth and sixth messages are encrypted, okay. So here we are sharing our identification information, right? Whatever the identification information that we are sharing, that contains the, okay, uh, private information which are encrypted here. But when I go with aggressive mode, so this identification will be shared in a plain text, okay. If anyone having, okay, if anyone in the internet will able to capture your data, they are going to get your private information, okay. That's the reason we are going with main mode, okay. We in the main mode we will be having encryption, okay, in the fifth and sixth phase, whatever the identification that we are sending, so we will be having an encryption. But here the identification information will not have any encryption, it will be going to share in a plain text, okay. So that is the reason we are going with main mode, okay. So if I keep all this in an tabular format, so in the main mode we'll be having 6 messages, in the aggressive mode we'll be having only 3 messages. Main mode is more secure because the fifth and sixth message, okay, the identification information we are encrypting. But aggressive mode is not secure, we are not using any encryption on the identification information. And main mode is slow process when compared with, okay, main mode is slow process when compared with aggressive mode, because main mode has 6 messages to process, so it will take a bit late, okay, bit time when compared with aggressive mode. But aggressive mode is faster because it has only 3 messages, okay. So we are going with only main mode, okay. Whenever you are configuring IPsec phase 1 between your branch offices. Okay, go with main mode whenever you are having whenever you are forming phase 1 between your branches. You can also go with aggressive mode. So when we have to go with aggressive mode means whenever you are not much concerned about the security and you want the tunnels to build very fast, so you can go with aggressive mode. But I'll prefer between the branch office or between site to site VPNs, okay, between site to site VPNs, I will prefer main mode only, okay, because of we will be having fifth and sixth messages are encrypted. Okay, so this is what the phase 1 contains, and these are the two modes that are available, and these are the messages that are exchanged in the main mode and aggressive mode. Okay, so next we'll be having an phase 2. So IKE phase 2, so like how we have modes in IKE phase 1, IKE phase 2 is also having modes. Only we have only one mode, which is an quick mode. So in the quick mode also we will be having three messages that are going to exchange between the firewalls, between our branch office firewalls, and all the three messages are encrypted. Do you know why? What is why all the three messages are encrypted? Any guess? Anyone? So in the quick mode, we are also going to exchange three messages, and these three messages are encrypted. We don't know what exactly the firewalls are negotiating in the three messages. We can see all are encrypted. So any guesses here? Why the three messages encrypted? But in the phase 1, we can see all these six messages if you are using main mode, and you can see all these three messages if you are using aggressive mode. But whenever you are whenever you see the quick mode three messages, all the three messages are encrypted. Any guess why these three messages are encrypted? Anyone? So
For faster connection, bro.
faster connection? No, faster connection will be having three messages. That's okay, but I'm asking the encryption part. Okay, why three messages are encrypted? So we have already discussed about phase 1, right? This phase 1 is mostly used for to exchange or to forward the management traffic, right? And as well as phase 2 information, right? We are already discussed about phase 2 information. Now our phase 1 tunnel is already formed. Okay, this is a phase 1 tunnel. Our phase 1 tunnel is already formed. So in this phase 1 tunnel, our phase 2 information is exchanging. Okay, this information is going to exchanging between your firewall 1 and firewall 2 in this tunnel. Okay, we are already formed phase 1 tunnel, which is a secure one. So that is the reason whenever we capture the information here, you can see this information, but you cannot see this phase 2 information. Okay, why? Because we are sharing the information, or we are exchanging the information inside the phase 1 tunnel. This phase 1 tunnel will be used to exchange the phase 2 information. Okay, so even though we have formed an phase 1 tunnel, so we have already formed phase 1 tunnel. So inside the phase 1 tunnel, we are exchanging the phase 2 information. So whatever the information that is required to build up and to build an phase 2 tunnel, so we are exchanging inside the phase 1. That is the reason we can see all the three messages are encrypted. Okay, got it? Any confusion or any doubts here? Got it, right? Why we see the three messages are encrypted? Any questions, guys, or any confusion here?
సార్ ఆ 3 మెసేజ్ ఎన్క్రిప్టెడ్ డేటా అలా అది ప్రాసెస్ ఎట్లా అయింది సార్?
ప్రాసెస్ ఎలా అవుద్ది అంటే, ఆల్రెడీ మనం ఇక్కడ phase 1 phase 2 పారామీటర్స్ ఆల్రెడీ కాన్ఫిగర్ చేసాం. The firewalls will take care of that. Once you configure everything, they are going to exchange, and they are negotiating. If any parameters is mismatching, they will not form tunnels, or if everything is mismatching, they are if everything is matching, so they are going to form phase 1 and phase 2 tunnel.
సార్ ఫేజ్ 1 టన్నల్ అంటే కంట్రోల్ టన్నలా సార్? ఫైర్ వాల్ లో కంట్రోల్ తీసుకుంటారా?
కంట్రోల్ అని చెప్పం. సో మేనేజ్మెంట్, ఓకే, మోస్ట్లీ ఫర్ మేనేజ్మెంట్ అండ్ ఆల్సో టు share our phase 2 information. We can call as management tunnel as well. Phase 1 is a management tunnel as well. Okay. Yeah.
సార్
Go ahead. Yes.
సార్ ఫేజ్ 2 అంటే అది ఏ టన్నల్ కింద వస్తుంది సార్? డేటా టన్నలా, మేనేజ్మెంట్
Yes.
టన్నలా?
So phase 1 will be an management tunnel. Okay. Phase 2 will be an data tunnel where our information, okay, where our exact information is going to exchange. Okay. Our user traffic will be there, right? That user traffic will be flow inside the phase 2 tunnel. We can call it as a data tunnel as well. Yes. I will tell that. Okay. Once phase 2 tunnel is done, I will draw one more picture and I will tell you. So see here, even though our three messages are encrypted, so we have to know what exactly the firewalls are going to negotiate. Okay. So in firewalls, okay, we are going to configure the parameters, right? Those parameters are going to exchange to form and phase 2 tunnel. So what are those parameters? Means these parameters contain, so in the phase 2 it is going to support the protocol. So in these protocols we'll be having two protocols. One is an ESP, another is an AH. ESP means encapsulation security payload, and AH means authentication header. Okay. And along with the protocol we'll be having okay, authentication. So the same thing, okay, whatever we have discussed on the phase 1, we'll be having same thing here on the authentication. And it will also having a group, okay, which will be calling as an DH group. Lifetime, okay, I told, right, each and every tunnel will be having its own lifetime. So by default on the Palo Alto firewall you can see the lifetime of phase 2 tunnel is 1 hour, and the next one is an encryption algorithm. Okay, so it is going to use encryption algorithms here. So these are the these are the parameters that are going to exchange in first two messages of, okay, quick mode. And if any of the parameters are mismatching, like how we discuss here in the phase 1, the phase 1 tunnel will not, sorry, phase 2 tunnel will not form. If phase 2 tunnel will not form, our data will not be, okay, flown. Our actual data will be there. Okay, if the phase 2 tunnel will not form, our actual data will not be, okay, sent between your branch offices. So if you want to form phase 1 and phase 2 tunnels, so every parameters that we have configured should match on both sides. If any of the parameters are not matching, the data will not be, okay, if any parameters is not matching, the tunnels will not form. If the tunnels will not form, our data will not be shared, okay, will not be initiated. Okay. And here we have discussed about the protocol, right? So let me brief about that protocols. So first we'll go with AH is an authentication header. So authentication header, we have, okay, this authentication header is a protocol. So every protocol has its own protocol number. So authentication header will be having a protocol number of 51. So what exactly this authentication header will do? Okay, so what it will do means, so let me draw a picture. Okay, so here this is our firewall 1 and this is our firewall 2. So now everything has negotiated, phase 1 form, okay, and the phase 2 information is exchanged inside the phase 1 tunnel. Now everything is completed on phase 2 as well. We have also formed phase 2 tunnel as well. Okay, so inside the phase 2 tunnel, whatever we are sending from our private subnet, okay, so here you will be having one user, and here also you will be having one user. So now this user is trying to communicate. Okay, So this user is trying to communicate from from your Hyderabad to Kurnool. Okay, Kurnool user is, from Hyderabad, the user is trying to communicate with the user in Kurnool. Okay, so now let's suppose you are trying to ping. Okay, you are trying to ping from Hyderabad to Kurnool user. Okay, Hyderabad user is trying to ping to the Kurnool user. So this is our, we can consider this ping traffic. Okay, this we can consider this ICMP traffic as an our actual data. Okay, so now phase 1 is completed, phase 1 tunnel formed, and phase 2 is completed, phase 2 tunnel is formed. This ping traffic, ICMP traffic will be there, right? The ICMP traffic will be flown inside the phase 2 tunnel. Okay, the ICMP echo request is flown inside the phase 2 tunnel. So how it is flowing, right? So this information will be in the, in this payload. If you are using AH, this AH will be as a payload here. Okay, this AH will carry your ICMP echo request packets. Okay, so if you take a packet capture, you can see first you can having an physical header. Okay, physical layer L1 header, you will be having Ethernet header and IP header, you will be having UDP header. After that you will be having an payload, right? This payload is an your protocol, whatever the protocol that you are using, this payload will be having your protocol, and this payload will carry your actual traffic. Okay, this is this L1 L2 L3 L4 will help you to build a tunnel, and this payload will be there, right? This payload will carry your traffic, actual traffic, whatever the information that we are sending from your Hyderabad user to Kurnool user, this AH will carry your payload. Okay, if it is an ICMP packet, the AH will be inside the ICMP inside the AH packet or AH payload. Okay, so what AH will do means, so it is going to provide authentication and integrity only. Okay, authentication and integrity to your actual data. Okay, authentication and integrity to the actual data. So here in this case, what is our actual data? Our ICMP packet will be our actual data. Okay, so why we are already have authentication integrity already completed in phase 1 phase 2 tunnel, why again we are having an authentication integrity to the actual data means, so we are mostly concerned about our actual information only. So why we are forming phase 1 and phase 2 tunnel? So to secure our, or to securely send our information securely inside the phase 1 phase 2 tunnel. Okay, so why again we are having an authentication integrity? So I will discuss this later once I complete ESP as well. Okay, so this is an AH where it is going to provide authentication integrity to your your actual data. So what is an ESP then? Okay, ESP is an encapsulation security payload. Okay, so ESP is also a protocol which will be calling in the security payload, which will be having an protocol number as 50. Okay, so what exactly the ESP will do means, ESP also will do authentication integrity. Okay, along with the integrity, okay, along with the integrity, it will also going to provide encryption to our actual data. Okay, so why we are using this? Already we have, already we have formed authentication, we have used integrity, we have used encryption, and on phase 1 and phase 2 tunnels, why again we are encrypting here in the payload? Why? Because, so if any attacker will be there, okay, so if any attacker sitting in the internet, if they are using any advanced tools, if they, if they try to break our phase 1 tunnel and as well as phase 2 tunnel, they are going to capture our actual information, right? If they also capture our actual information, to provide extra layer of security, we are using AH and ESP. But okay, if you use AH, we don't have any encryption to our actual data. Means whatever the information that we are that the attacker is going to get, that they can see our actual information in the plain text. But if you use ESP as a protocol between your phase 1, between your branch offices in phase 2, it will also provide encryption to our actual data, which if the attacker break our phase 1 and phase 2 tunnel, and if they try to capture our information, our actual data will be in the encrypted format. Okay, so mostly we can prefer, so the ESP as a protocol whenever you are forming an IPsec phase 2 tunnel between your branch offices, we can go with ESP. By default, ESP is also there, but if you want AH also you can use, but more extra layer of security, so to your data, so we can use ESP as a protocol. Okay, we can here the ESP will be added as a payload. Okay, ESP will be added as a payload here. So whatever the ICMP packet will be there, right, that will be contains inside the ESP, and this ESP will be trying to that ESP payload or the ESP packet will be encrypting our actual information, which is in this case the ICMP packet. So if you see the ICMP packet, what it contains, we'll be having MAC source MAC destination MAC will also contain source IP destination IP, right? That will all are private subnets or private information. So to avoid exposing those information towards the internet, we are using one extra layered security in the form of these protocols. ESP will provide authentication integrity, but AH will provide authentication integrity, but ESP will provide authentication integrity and as well as encryption to our data. Okay, so this is what that this is what we are going to do and in the IPsec. So this completes our IPsec class as well. So once the phase 1 phase 2 tunnel will be formed, our actual data will be flown inside the phase 2 tunnel, and these protocols will be carry our actual data. Okay, so these protocols will be having as a payload here after your L4 header, and this payload will carry our traffic. If you are using AH, our traffic will be in the AH payload, and if you are using ESP, and our actual data will be inside the ESP payload. Okay, so this is how the IPsec is going to use to protect your information or to protect to exchange the data in a secure manner. Okay, so any questions guys here, anything that you want to know, or did you got it, how IPsec will be used to exchange the information in a secure manner? Are able to follow me, right?
Yes, sir.
Yes, bro.
Any questions?
Sir, in the main mode, lifetime is 8 hours, right?
Oh,
Can we change it or
yeah, we can change.
is
This lifetime
fixed?
is configurable. You can
Okay.
configure a maximum of up to 365 days as well. Same in the phase 2 as well. By default, the lifetime will be 8 hours in phase 1, and lifetime will be 1 hour in the phase 2. Both will be configurable. If you want, you can also change that, but lesser the lifetime, more will be the security to your to your data, or there will be an yeah, more security to your data. So there will be often our IPsec tunnels we're going to exchange the data or exchange in the parameters. If any changes, it will break your data, or if you break the tunnels, and if there is no changes in your parameters or there is no changes in the configuration, it will renegotiate, and it will be again lifetime will be reinitiated, and from that it will started again.
Yeah, okay.
Yeah, any questions?
Sir,
Yeah,
సార్ కార్తీక్ సార్
yeah,
సార్ ఫేజ్ 2 ఎక్స్పైరీ డేటా ఎప్పుడైపోద్ది సార్?
maximum 1 hour. Okay, maximum in sense
మాక్సిమం 1 అవర్.
default 1 hour, maximum is 365 days. If you want to configure, you can configure 365 days as well.
1 సార్ ఫేజ్ 1 సార్ ఫేజ్ 1 ఎక్స్పైరీ డేట్ ఎప్పుడైంది సార్?
Phase 1 will be having only 8. Okay, by default it will be having 8 hours, default one. But if you can also configure 365 days.
Sir, here this is more time, right? So if
Ah,
the parameters are not matches, we have to wait 8 hours. That is more time,
8.
right?
We have to wait 8 hours. That's correct. So if you don't want to wait, if you change, okay, if you change any parameters, if you want to renegotiate the parameters, we can manually initiate the tunnel traffic. Okay, that we can do from the firewall. But if anything changes unknowingly, so the tunnels will wait for 8 hours to renegotiate.
Can we modify it or
We can modify.
8 hours?
Yeah, we can
Okay.
modify.
Modify 1 hour and two
Yeah, we
hours
can
as well. Can we
modify to 1 hour or 2 hours, or we can also modify in
Okay.
seconds. You can modify in minutes. You can modify in
Okay.
hours, or you can modify in days.
Yeah. Okay, sir. Got it. Thank you.
Yeah, yeah. Any questions, guys?
సార్ ఇప్పుడు ఫేజ్ 2లో లైఫ్ టైం ఎక్స్పైరీ అనేది ఎప్పుడైపోద్ది సార్?
లైఫ్ టైం ఎక్స్పైర్ అదే చెప్పా కదా, బై డిఫాల్ట్ 1 అవర్ ఉంటుంది. 1 అవర్లో నీకు రీనెగోషియేట్ జరుగుతుంది. ఒకవేళ రీనెగోషియేట్ జరిగినప్పుడు పారామీటర్స్ ఏమైనా మిస్ మ్యాచ్ అయితే ఫేజ్ 2 టనల్ డౌన్ అయిపోతుంది. సో ఫేజ్ 2 టనల్ డౌన్ అయినప్పుడు మనకి యాక్చువల్ డేటా ఇన్ఫర్మేషన్ షేరింగ్ జరగదు. సో ఇఫ్ యూ వాంట్ టు కాన్ఫిగర్, యూ కెన్ కాన్ఫిగర్. ఓకే, ఇఫ్ యూ వాంట్ మోర్ phase 2 లైఫ్ టైమ్, యూ కెన్ ఆల్సో కాన్ఫిగర్. యూ కెన్ కాన్ఫిగర్ అప్ టు 365 days. Yeah, any questions, guys? Yeah, okay. I will take it as no. Okay, so I think
Bro, 1 minute.
yeah, go ahead.
సార్ సార్
Yeah,
ప్రీవియస్
anyone. Yeah,
లో
Putran.
మనము ఎస్ఎస్ఎల్ డిక్రిప్షన్ చూసి టన్నల్ క్రియేట్ చేసాం కదా
Ah,
ఫర్ డేటా ట్రాన్స్ఫర్.
oh,
అంటే ఇవి 2 డిఫరెంట్ మోడ్సా ఎస్ఎస్ఎల్ అండ్ ఐపీసెక్ ఆర్ 2 జరగాల ఫేస్ బై
no,
ఫేస్?
no, no, no. IPsec is different, SSL is different. SSL is a different concept where you are forming tunnels between client and server. Okay, but this is
ఓకే.
an IPsec is a different concept where you are forming a tunnel between your branch offices, site to site. That is client to server, this is site to site.
ఓకే. బిట్వీన్ ఇంటర్నల్ అంటారనమాట అయితే.
అదే, నీకు ఒక ఆఫీస్ ఉంది. మీ ఆఫీసు
హ్మ్.
ఒక బ్రాంచ్ ఆఫీస్ వచ్చి హైదరాబాద్లో ఉంది, ఇంకో బ్రాంచ్ ఆఫీస్ వచ్చేసి బెంగళూరులో ఉంది. ఈ బిట్వీన్ బ్రాంచ్ ఆఫీస్లో మీరు ఏదైనా ఇన్ఫర్మేషన్ షేర్ చేసుకోవాలి విచ్ ఈస్ కాన్ఫిడెన్షియల్, దట్ యూ కెన్ యూస్ ఐపీసెక్. But SSL is different, which will be between client and the server. Okay, client in sense, client will be an Windows machine, server is anything that you are going to access. Okay, if suppose Facebook you access చేయాలనుకుంటున్నారు, Facebook access చేయాలి అంటే, so you need to reach the Facebook server. So between the your client and Facebook server there will be an internet, right? So if you
యాహ్!
want to exchange, okay, if you want to get the data, or if you want to send any request securely, that request has to be go through the internet. So if you don't have any security between your client and your server, maybe your information will be, okay, take your information will be exposed in the internet, and someone will be going to capture your data. So to avoid that, we are forming one secure SSL tunnel between your client and your Facebook server. Client is an Windows machine where you are going to browse, okay, and server is whatever the browse, okay, whatever you are browsing, whether if it is Facebook, that will be Facebook server. If it is Instagram, that will be an Instagram server.
యాహ్! ఓకే. అంటే మన కంపెనీ సిస్టమ్ నుంచి ఇంటర్నల్ సర్వర్‌కి
Maybe
మనం
internal
టన్నల్ క్రియేట్
internal అని చెప్పాం,
చేయాలని.
అది ఎక్స్టర్నలే ఉంటుంది.
హ్మ్.
We are
ఓకే.
forming an tunnel in the sense we are reaching the into the internet only. So here also the firewalls are not directly connected. Okay, the firewalls are between, okay, the internet is between your branch offices. So మనకు ఒక ఇన్ఫర్మేషన్ హైదరాబాద్ నుంచి బెంగళూరు సెండ్ చేయాలంటే మనం డైరెక్ట్గా కేబుల్ లే చేయలేం కదా. So
ఓకే.
first it has to be go through the, okay, some routers, or it is going through the Hyderabad ISP. from Hyderabad ISP to Bangalore ISP, there will be an separate links. So your information going through via those, and from Hyderabad Bangalore ISP to, it will reach your Bangalore office. So between your office, between your Hyderabad office, Bangalore office, there will be multiple devices will be there, which is sharing via internet and which is sharing via ISPs. So if you want to form, or if you want to share your information securely, we are forming logical tunnel. This is not directly connected. We are logically forming an tunnel between your branch offices by using all these features.
Yeah, understood, bro. Thanks.
Okay. Yeah, Sairam, you are asking something.
సార్ ఇప్పుడు విపిఎన్ కనెక్టివిటీ ఈ లొకేషన్ నుంచి ఆ లొకేషన్ కనెక్టివిటీ అవుతాం కదా సార్ ఇప్పుడు యూజర్స్ డైలీ ఆఫీస్లో. ఇది అయ్యేటప్పుడు ఇప్పుడు పాస్వర్డ్స్ అనేది అది సర్వర్ టీమ్ క్రియేట్ చేసిద్దా సార్, నెట్వర్క్ టీమ్ ప్రొవైడ్ చేస్తుందా?
That will create, that will be a different concept, that we can discuss in global protect. I will tell you.
సార్
But
మరి
to
ఇప్పుడు ఆ
your
పాస్వర్డ్స్ అనేది
question,
మీటింగ్ అయిపోగానే ఎక్స్పైర్ అయిపోద్దా సార్?
ఏదేంది?
ఇప్పుడు వాళ్ళు మీటింగ్ కనెక్టివిటీ అవ్వటానికి ఈ లొకేషన్ నుంచి వేరే లొకేషన్కి వాళ్ళు మెయిల్ రేస్ చేశారనుకోండి, అప్పుడు ఇంకా వాళ్ళు పాస్వర్డ్ సెండ్ చేసిన తర్వాత మీటింగ్ అయిపోయిన తర్వాత ఎక్స్పైర్ అయిపోద్దా సార్ ఆ పాస్వర్డ్, యూజర్ ఐడి పాస్వర్డ్?
మీటింగ్ కనెక్ట్ అవ్వడానికి యూజర్ ఐడి పాస్వర్డ్కి ఏం సంబంధం? ఏ మీటింగ్ గురించి అడుగుతున్నాను?
ఇప్పుడు ఆఫీస్లో యూజర్స్ కనెక్టివిటీ అవ్వటానికి ఈ లొకేషన్ నుంచి వేరే లొకేషన్కి VPN కనెక్ట్ చేయమని అడుగుతారు కదా సార్.
అవును.
అడిగితే ఇప్పుడు వాళ్ళు వాళ్ళకి VPN కనెక్టివిటీ మీటింగ్ అయిపోద్ది కదా సార్, వాళ్ళకి 2 అవర్స్ మీటింగ్ అయిపోయిన తర్వాత ఆ పాస్వర్డ్స్ అనేది ఎక్స్పైర్ అయిపోతుందా సార్ అంటున్నా?
నీ పాస్వర్డ్ ఎప్పుడు ఎక్స్పైర్ అవ్వదు. వాళ్ళు ఒక డేటాబేస్ మెయింటైన్ చేశారు. ఆ పాస్వర్డ్కి కూడా, అంటే ఐ మీన్ పాస్వర్డ్ నెవర్ ఎక్స్పైర్స్. ఇఫ్ దే హ్యావ్ ఎక్స్పైరీ, సో దే ఆర్ గోయింగ్ టు, వాళ్ళు మళ్ళీ చేంజెస్ చేయడానికి ఉంటుంది. బట్ ఐ థింక్ పాస్వర్డ్ విల్ నెవర్ ఎక్స్పైర్. You have to use the same password every time whenever you want to log into the VPN. But that is different thing. That is, you are going with out of topic, that is remote access VPNs, that we'll discuss in the global protect class. But if you have any questions in the site to site related to IPsec, just let me know. Any questions, guys, related to the IPsec? Yeah. Okay. If you don't have any questions, we can wind up this session here. Okay. So we can, tomorrow will be, there will be a no class tomorrow. We can meet on Monday, so we can complete the IPsec lab. Okay. So on Monday we'll going to do an IPsec lab. We'll complete that lab on Monday. Okay. Thanks, guys. Thanks for joining the session today, and have a great weekend. Bye.
బ్రో నోట్స్ సెండ్ చేయండి.
Yeah. Okay. I'll share. Yeah.
థ్యాంక్ యూ.
Okay, guys. Bye.